We now discuss the solution of a problem from the section three-dimensional geometry, and the problem is on the angle between two planes. This question has appeared in the joint entrance examination main held on 24th June 2022 in the second shift. The problem is, let the points on the plane P be equidistant from the points with coordinates -4, 2, 1 and 2, -2, 3. Then the acute angle between the plane P and the plane 2x plus y plus 3z is equal to 1 is, we are given four options. Option A, pi by 6. Option B, pi by 4. Option C, pi by 3. Option D, 5 pi by 12. So we are given a plane P, and the points on the plane P are given to be equidistant from 2 points. The first point is -4 to 1, and the second point is 2, -2, 3. And we are also given another plane 2x plus y plus 3z is equal to 1. So required to find the acute angle between the plane P, the above plane P, and this plane 2x plus y plus 3z is equal to 1. We now discuss the solution of the problem in detail. We have a plane P and 2 points A and B with coordinates -4, 2, -4, 2, 1 and 2, -2, 3 respectively. This is the plane P, and this is the point A and the point B, and it is given the points on the plane P are equidistant from A and B. From A and B, the points of the plane P are equidistant. So if you take the point P, it is equidistant from A and B. If you take this point is equidistant from A and B. So now the line joining A and B intersects P at a point Q. The line joining A and B intersects the plane P at Q. This implies Q is equidistant from A and B. Why? Because the points on the plane P are equidistant from A to B, and Q is the point on P. Therefore, Q is equidistant from A and B. This means Q is the midpoint of the line joining A and B. Agreed. Therefore, the point Q is given by, use the midpoint formula, that is -4 plus 2 by 2, 2 plus -2 by 2, 1 plus 3 by 2, and that is the Q is given by -1, 0, 2. Agreed. Now further, note that the line AB is normal to the plane P. So the line joining AB, the line joining A and B, that is the line AB, is perpendicular to the plane P, and that is why it is called the normal to this plane P. And the coordinates of A and B are known. Therefore, the direction ratios of the line AB can be found out. That is, the direction ratios of the normal to the plane P can be found out. And its direction ratios are given by 2 minus of minus 4, that is 2 plus 4, minus 2 minus 2, that is, and 3 minus 1. So these are the direction ratios, that is 6 minus 4, 2 are the direction ratios of the normal to the plane P. So now our plane P is passing through the point Q, having the direction ratios of the normal to the plane P as 6 minus 4, 2. So now the plane P is passing through the point Q with coordinates minus 1, 0, 2, and the direction ratios of the normal to the plane are 6 minus 4, 2. Now we can write down very easily the equation of the plane. That we do it in the next slide. We have the plane P is passing through Q with coordinates minus 1, 0, 2, and the direction ratios of the normal to the plane are 6, minus 4, 2. And we can write down the equation of the plane P. We recall the equation of the plane through a point x1, y1, z1 is a times x minus x1 plus b times y minus y1 plus c times z minus z1 is equal to 0, where a, b, c are the direction ratios of the normal to the plane. So a, b, c in our case is 6 minus 4, 2 respectively. x1, y1, z1 is minus 1, 0, 2 respectively. Now we can write the equation of the plane P is given by A, that is 6 into x minus x1, x minus minus 1, x plus 1, minus 4 into y minus 0 plus 2 into z minus 2 is equal to 0. So simplifying, we'll get 6x minus 4y plus 2z plus 2 is equal to 0. Cancelling 2 throughout, the equation of the plane P is given by 3x minus 2y plus z plus 1 is equal to 0. Now we given another plane P prime whose equation is 2x plus y plus 3z minus 1 is equal to 0, and required to find the acute angle between these two planes. Let theta be the angle between the plane P and the plane P prime. Now we recall the angle between two planes formula. If theta is the angle between the planes a1x plus b1y plus c1z plus d1 is equal to 0, and a2x plus b2y plus c2z plus d2 is equal to 0, then theta is equal to cos inverse of, in the modulus, mod of a1 a2 plus b1 b2 plus c1 c2 by under the square root of a1 square plus b1 square plus c1 square under the square root of a2 square plus b2 square plus c2 square. So this is the formula for the angle between two planes P and P prime. Now theta is equal to cos inverse a1 a2 3 into 2 plus minus 2 into 1 plus 1 into 3 by under the square root of 3 square plus minus 2 square plus 1 square. Agreed. And in the denominator again under the square root of 2 square plus 1 square plus 3 square. Now multiply these things and add, simplify it. We'll get cos inverse of, the numerator is 7 by under the square root of 14 multiplied by under the square root of 14 again in the denominator, and that will be 7 by 14. Cos inverse of, that is equal to cos inverse of 7 by 14. that is cos inverse of 1 by 2, and we want the acute angle. Therefore, the theta will be cos inverse 1 by 2, that is pi by 3. Let's look at our options. Our answer pi by 3 appears against option C. Therefore, our answer to this question is option C. So that is the detailed discussion of the solution of a problem from the three-dimensional geometry, which is to find the angle between the two planes. I'm sure that you have understood the solution of this problem, and I wish you all the best. Thank you.